Yeah, all right. So last week, what did we do? And maybe those of you that were here last week can help out. We had something like square root of 12, and we had to simplify it a little bit. All right? What is that? What can that simplify to? Yeah, with a little bit of work that you may or may not remember, 2 root 3, right? Okay, perfect. I think recently we had something like 3 times square root of 6 times the square root of 8. What does that equal? Beep, 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 beep. Or maybe what does it equal? How do you get it?
Well, root 3.
12 root 3, maybe. Should we check? Oh, earthquake. Should we check and see? A little warm-up reminder. How the heck do you solve this thing? 3 root 6 times root 8. Well, 2 different ways. What's one of them? We could,
One of them, we can multiply the 6 and 8 and
okay,
put it in the root.
perfect. And then do stuff, right? So you said, and then, so times or multiply, same thing, right? So you could times 6 with the 8, multiply 6 with the 8. Sure, you can do that. Then we get 48. This is one method to solving this thing. What happens next?
Then the factorizing get 48.
Sure, factorizing. So what does that mean? There's 2 ways we can do that.
We can do the like 3 thing,
Yeah.
and we can do, yeah, and we can do root the 8 like divide 2. Root 8 divide 2, then this one.
Oh yeah, that's this one here. You can have 48. It's a little factor tree, it's called.
No, how can I say that like this one?
Sure, go ahead. You can erase that. We know that Nico's good at FIFA. That's okay. Oh, that one. So that's called repeated division.
Okay.
Yeah, and that's kind of like the same as the factor tree in a way. You break down the factors and you see what you get. Okay, I could show that afterwards. So we have the factor tree as one of the methods. The other one is write this with a square number. That is right, 48. So we have a square number showing up in there. What are our square numbers? 1, 4. Yeah, the actual squares. 9, 16. Right? 1 squared is 1. 2 squared is 4. It's a list you got to know. Yeah. Which one can work? True, it does. What's a bigger one? The biggest one is the best one. And because I'm running out of real estate here, running out of paper, what's the best one? Yeah, I think I heard it. 16? Yeah. 16 and what? Nicely done. Okay, so we're breaking down the 48 one of 2 ways, to a bunch of prime factors or square and a factor. Today, a square and a factor. So we get a 3 like this. We get our 16 that you just said, which is correct, in there. All right. Yeah. It will be 4, but I'm going to hang on because everyone was kind of quiet in the beginning. With square roots, radicals, or surds, as I believe that for a new guy here, they can be split up into two parts that multiply together. Kind of use this trick in the beginning. They were separate, put them together. Now they're together, we can separate them. Yeah, we're allowed to do that. What's the square root of 16 now? 4. What's the square root of 3? Square root of 3. Final answer. 12 root 3 like that. Okay, so well done if you got it. Is this a nice reminder for those of you who working on this last week? Yeah? Yeah, right on. Okay. So if you need some help with this, we'll have some time during class to take care of that. Let's go through some of the new stuff first here. Okay, this was all last week's stuff. New week, this week, day 6. What we got to do is we got to start taking a look at exponents and then all of the, they call them rules, but it's more like properties. We don't make up rules just for fun. The universe gives us these things and we have to work with them. That's kind of the deal. All right, so what do we got? Well, first of all, there's this thing called probabilities. Does anyone know what those are? What does probability mean in English? If you had to explain it to someone. Chances. Yeah. The odds. Nice. The chance of something happening, right? Chance of rain right now? 90%, if not 100. Right? Chance, let's say you have a coin. Chance of flipping heads and tails, right? What's that chance going to be? Yeah, 50-50 for a coin, right? Probability. Okay, now, with a coin, that's kind of cute and fun, right? You got heads on this side. I guess that's a head. And then you got whatever's on the other side, right? So you flip the coin, 50% chance of getting heads, and then a 15% chance of getting tails, right? Okay, now this is important in math because there are more interesting things than heads or tails that we can still use this topic for, right? What are the chances of rain? We just said that, right? That's important. Farmers care about that. Right now, Canada is a huge country. We depend on selling our agriculture. Right now, the farmers are wanting some rain to happen, right? What's the chance that it's going to happen? Okay. This has an effect on decisions they make. How much fertilizer, what type of fertilizer, what plant to plant, and then what does that all mean? How much money they're going to spend and how much money they're going to make from doing their job and making decisions that depend on probabilities, right? What's the chance of someone getting into an accident by driving 120 kilometers an hour down the street there? Pretty good, right? Yeah. How much should their insurance be then? Ah, you know what insurance is then, eh? Yeah. Okay, so see? So if the probability of not H, yeah, H for high speed now, not heads. Okay. If the probability is high, then yeah, the insurance should be expensive. Okay, for us regular guys like myself, well, if that's 90, that's 10, has to add up to 100, right? If that's 10, then I should be able to enjoy a low-cost insurance, right? So that's all related to the probability. Now, how do probabilities relate to exponents? What are the chances of, when you're flipping coins, getting 3 heads showing? Half? This you might not know, so I'm telling you for free. You get a half each time, and you multiply them together. Okay? This is 1, 2, 3 numbers. How many cars are out there in the city right now? Let's say 200,000. 1.2. You can correct me if I'm wrong, but 1.2 million in the Vancouver area. So 500, what did I say? 200, that's 1/6. of the people. Okay, half are too old, half too young. Well, that's everyone. So I mean the third too old, third too young, leaving a third in the middle. So what do you think? 200, is that too high? Point is, you're not going to write 200,000 values down, right? What are you going to do? You're going to be smart. You're going to say, okay, this is still a bit silly to be honest, but it shows, you know, kind of shows the smart way of doing things. Multiplying probabilities together, using some exponents to save a whole lot of pen ink and paper in order to communicate what it is we're doing, right? What do we do with this? As you just said, insurance, crop fertilizing, okay? So to get these numbers, to work out the finance, to work out the money part, yeah, you got to know how exponents work. And that's what we're doing. So taking a look at the screen now. We got screen up there and we got camera down here. Okay. What do we got? A review from last week showed you this one exponent fact just to kind of get started. We're going to use it more today. All right, just a shorthand, right? Do you all remember the slide that we had for this? What it looked like? What sort of things were on the slide when I was showing you this fact? Can't remember? Yeah, there we go. Y's, twos, and smiley faces, right? That one. So anyways, all it is just a shortcut for writing all the X's, all the things that are multiplied together. There are 5 things all multiplied, so you got a 5 up there upstairs, right? You can have more than just X's and Y's multiplied together. Depending on the meaning of the questions, you might have a different letter R altogether. But then you start getting fancy things. Class, can you see that? That's a 4X on the inside. Does it need to be bigger for you? It's okay? No smaller though, right? That's as small as it goes. Okay, so something like 4X on the inside now, right? Okay, how do we deal with that if we have 200,000 of these things? Okay, how about something like this now? You know, I'm just making this up, but this might come from some farmer's field, some physics problem. This might actually have some real meaning, right? We got to look at it. Okay, so how do you deal if it's an expression now? We got some numbers in there. How do you work out with the -3 in the front there? What do we do with that? Okay, these are what we're looking at today. And so, just to show you, because I know you guys are curious and wanting to know what the heck. First one, XXX is going to be equal to what? X to the power, yeah. X to the 3, X to the power of 3. Yeah, both of those, okay. The next one, how many Y's are there? 6? Okay, I'm going to trust you. Oh yeah, 3s and 3s. 6 down there. The next one. 5R, done. You could just be cute and write it like that. But of course, I think they're wanting to remind you, you can multiply it out as 1, 2, 3, 4, 5 R's like that, okay? Next one, starting to get a little more interesting. What do we have here?
16.
If it was a 2, but I think it's a 3 if I zoom in there. I'm going to pretend it's a 3. So I'll put it here on camera officially. Zoom, you can help out too. I see you 3 officially. 64x to the 3. Yeah. Yeah, good. Now, just for today, I'm going to show you the longer version. X to the 3, whatever to the 3 means there are 3 of these things multiplied together. So that's 1, that's 2, that's 3. This is what pops out in your brain when you look at this. Okay. And this is nice to visualize this in your head, because then you can start thinking about the different parts. The number part. 4, 4, 4. These are all multiplied together because how it's written there. So you break out your fingers and toes. What's 4 times 4? Good. 16 times another 4. Yeah, 64 as was said. Okay. It's true. Then x times x times x, what do we got there? Yeah, I could write it out all like that, but that'd be a little silly for this exercise. X to the power of 3, right? So I'm just showing you now. We'll do it officially later on. There's a little shortcut, different way of doing this. That'll be nice for you to know. The last one, it's still a 3.
-3 xy 2.
Okay, Mark, I heard you're minus 27. Zoom, I heard a little bit over there. It is. Skipping to the final answer. What the heck? How does that come? So remember, this 3 means there's 3 of these all multiplied together. Okay, so that means we have a minus 3xy squared. That's 1. We get another one. You see? Visualizing it out like this. Numbers first. Minus 3 times minus 3 times minus 3. Minus 27. It is, right? Okay, you can check that out. Looking at the x's. X, x, and x. Same as before. X is a 3 now, right? Okay. Now this other one, this kind of gets into today a little bit. I'm running out of space, so I'm going to put it up here. But what we got is, we got y squared times y squared times y squared, right? It's nice. How many y's are being multiplied in this part? 2. Because that's a 2 there. How many y's in this part? 2. How many y's in that part? 2. So what is the effect now of all of these y's, the result of all these y's multiplied together? That is, how many are there? 1, 2, 3, 4, 6. Yeah, that's it. Okay, so when we go through to today's topic, visualize this happening, right? That'll help with the results you get. Right, so we got those examples started there. Yeah, now what we got here, so I call them facts on the slide. I call them properties. In your textbook, if you had one, you'd see that as rules of some sort. Okay. Got rules there. I want to start creating some shortcuts so that we don't have to write out 200,000 of these. Whoops, not that page. It's on the back here. So that we don't have to write 200,000 of these terms out, right? Shortcuts. So this is the first one. We got there with the r's at the top of the page there. R squared times r cubed times r squared is equal to r to the power of 5. All right. If you don't believe me, we can do this. Cubed is first, right? Yeah. Officially, it doesn't have to be. When you multiply, you can flip the order around. An example with numbers, 2 times 3 is what? 6. 3 times 2? 6. You see? Same. So multiplying allows that to happen. Now, from your brain, how many r's are there here? All 3. And how many here? 2. Making a total of 5, right? So in your head, okay, remember you can see something like that. So that should make sense. Okay. But what I do is come up with the shortcut, a rule. And what that involves is making a connection between what we got here what you see in the original part, if you like, and then what you get is a final answer. So how the heck can we get from these three, from this 3 and this 2 over to 5? That's it. 3, 2 to the 5. What to do? Secret, right? It's just 3 plus 2 is going to equal 5, right? Okay. And so this shows us now what a shortcut or a rule that we can use when we're multiplying these things together. Okay. We're going to do some adding. Add the original. What are these things called? The 3 and the 2. That's a cube. Yeah. What part of the expression is it?
It's F number.
The pot. Yeah. Zoom, I think, got it. And we got an answer from class. So this 3 and this 2, this 5, you can call it the power. In other parts of the world, or at least in formal math, index. So I don't use it much here, but I know it's around. Exponent. That's what I use. Yeah. So to get back to our rules, you add the original exponents when what? What's the operation going on here? Times, right. When, if I can squeeze it in down here, multiplying. Yeah, timesing isn't really a word, but people know times, right? So I'll just put it like that. Beauty. Now, some special things have to be in place, or one special thing has to be in place for this to happen. What's the letter there? What's the letter there? So they both have to be? Not R, but yeah, both the same, right? Okay. What part of this expression? That part is called the base. Okay. And yes, in order for this to work, the bases have to be the same. So let's check it out. Let's do one for fun and then go back to the screen. Something like this. X to the 2, X to the 3, X to the 5. So first of all, the bases, what are they all? X for sure. And it's the same, just to show that we checked it, all right? Yeah, the second one, or the second thing to look for is that we're, all right, times, just because it's shorter than multiplying. Multiplying there, right? Okay, that's good. And so therefore, what does our rule say? Add the powers, add the exponents, right? Beauty. So what do we get? Yeah. X2 plus 3 plus 5, that will give x to the power of 10 like that. Yeah. Zoom agrees. Thank you, Zoom. Good to hear you. All right. Nice. How can we make this complicated? Throw numbers in there. Different types of bases at the same time. So you got to watch that x's go with x's, y's with y's. All right. But I think they come up in later slides. If not, I'll put them in there. Okay. Yeah, later slides, I guess. So here's the other one. What's going on here? Yeah, with this thing in this slide here.
Friday.
Yep. Zoom says dividing, I think, if I heard correctly.
Yeah.
Yeah, nice. That's what we got. And so explode in your brain, right? What all these X's are. So we can see what, to make sure we get this right. We got R to the 3 divided by R to the 2, R cubed divided by R squared. The long version is this for teaching effect. And this is a sneaky strategy you can always do. You can always just expand problems out, right? Take a look at them. Beautiful. So what can happen now? If you look at the top as divided by the bottom, you just do it letter by letter. So what's R divided by R? Yeah, 1 it is. Okay. So that's a 1. What's this R divided by that R? Good. Still a 1, right? So officially, and this is what happens in math sometimes, people just write down every detail and can make some people crazy. But these R's turn into the 1s that are there. That R is still hanging around. Okay. What's 1 times whatever? No. Whatever. Yeah. People always get that wrong because of the way, because the power 1 has. Don't worry. 1 times whatever is whatever. 1 times 10, 10. 1 times 7, 7. In this case, yeah, in this case, you are right though there. What is 1 times 1? 1. Times R? Final answer is R, right? Okay. So that's good. Now the same goal as before is to make a connection between the original situation, the original question, and the result we get at the end there. Yeah. So what do we do in this case? Well, first of all, recognize this R on its own has an invisible 1 that is there. We don't usually write it. We just get lazy and leave it off. Okay, but for our purposes, let's make sure that we remember there's an actual 1 upstairs there. Okay, good people. How do we get from a 3 and a 2 over to a 1? Yeah. From class, we got 3 minus 2, and I can agree with that. So that part works. When can we use this fact? Nice. The bases are the same. That's one piece of the puzzle for sure. And the other part is when, yeah, dividing as the sign says there. Okay, the same base. That's nice. And then with dividing. So let's check 1, and then we'll try and come up with, we'll just try and make sure this rule is true. Yeah, just to check it out. Oh, there we go. Looking good. Okay, so try this one here. Same situation, just bigger numbers, eh? Y7. I'll put X6 over X2, Y3. So you got pretty big already, eh? Not impossible though. So what you do is just go 1 letter at a time. Yeah. So taking a look at the X's. Yeah, it should be X4 by the time we work this out. Okay, for this one time only, we can do it the long way, where we got 6 X's all multiplied out, right? 6 X's on the top. We're looking at X's, so 6 X's on the top. 2 on the bottom. All right, so how can we check to make sure? Let's divide them out. Those divided with that one divided with that one. How many we left with? Yeah, 4.
Oh.
Nice. Zoom says 4 as well. Good. So does that match with our idea of 6 subtracting 2? That one does. Are the bases the same? Yep. They are both x. So this that term is looking good, or that part is looking good. How about the y's? Same thing? Y5 maybe. There's going to be 7 on the top. See, it's getting big enough. I don't want to write it all out now. Just go like that. So there's 7 y's on the top there. 3 on the bottom. And that's going to create the leftovers once we do the dividing, right? Yeah, it's going to be 4 this time. Yeah, for sure. Does that work with 7 and 3? Indeed, it does. Right? The base is the same? Yeah, absolutely. The base is y. And dividing all the way along, right? Beautiful. Okay. So there's a math way to show you, and that'll have like x's and m's and n's and stuff. But all it does is it shows this thing here. Instead of 6 and 2, it'll have m and n, and then there will be p and q or something. Right? Looks something like this. So, so for these couple of rules, when you got multiplying happening, xm times xn. Okay. What happens to the exponents when the terms are multiplied and the base is the same? Mn, not bad. That means multiplying m and n together. So what we just saw is adding them, right? If we need to go back for the multiplying, that was, yeah, this one, right? So adding them up, it'll be m plus n like that. More official math like. Number 2, guess what it's going to be? xm over xn. Right? Yeah, it'll be divide or dividing, just to remind you there. Same base. That's still there. Looking good on the screen. Yeah. How do we get them? A mathy version of subtracting those exponents from one another now. Yeah. Okay.
I have a question for Bertrand on this paper.
What's that?
Bertrand,
Turn this one. You remember what's on the other side? Yeah.
so basically, like, can I say, so x to the power 6 and then minus x2,
Yeah.
and then like y to the power 3 minus 7?
Yeah. Exact. That's how we get these values here. That's what these numbers here are showing.
Yeah, but it should be like there's a minus before one of the x and y.
A minus before one of the x and y.
Yeah.
Well,
the top, yeah.
I was going to say that that's a minus there, believe it or not. And that is a minus there, believe it or not. Okay. So I think, yeah, what you're saying, what I'll do is I'll do this question a different way. I'll do this question with what I just showed you. Okay. So what do we have? We had this x to the 7. X to the 7, that's a lie. X to the 6 over x2, y to the 7, right? Y to 3. So to show the rule, Yeah, you subtract those two because they're being divided, right? For these ones, they're being subtracted because they're being divided, same base. So yeah, that's actually what's going on. If you want to look at our M&Ns, what do you get? X to the 4, as you said, or maybe I said, and then X to the, or Y to the 4 is definitely you said. Okay. All right. So this is true with the rule. I'm suggesting if it's easy enough, you can just go right to that step there. Okay. Right. This is the third and last situation we got to look at today. We have multiplying, dividing, and then we have this thing. All right, so how does this work? We got, we'll say an exponent outside there. We'll make it look good there. Exponent on the outside. So you see that little 3 there? This 3 says there's 3 of whatever inside of the brackets all multiplied together. Okay. 1, 2, 3 sets of brackets because of the 3 on the outside. What's on the inside?
R2.
R2, not bad. R squared, yeah. R to the power of 2. Yeah, good. Remember with your brain, each of these can expand out. And so in your brain, you see a big row of R's there. How many R's are there? 6 in total, that's right. 2 from this set of brackets, 2 from that one, 2 from that one. Final answer, 6. Okay. So we could do this a few times. We'll see the same pattern result. And this is, this is my question right now. What the heck? How do we, how can we get from the 2 and the 3? Yeah, exactly. How do we get from the original 2 and the 3 to the 6? Watch, okay? The 2 and the 3, these are exponents. You multiply them together and you get the 6 that's there. Okay, so the challenge for you is to remember these different rules and these different situations and what happens. When to add the exponents, when to subtract them, and when you can multiply them together. Okay? So in this situation, the thing to watch for is that there's a bracket in between. I'll say bracket between, because you get these B's happening all the time. Okay, this bracket here is between one exponent and the other one. Okay, then this good stuff happens. Let's check it out. Try this other one. A longer version. X squared, yeah, x squared y will be good enough. We'll say it's cubed. What the heck does it equal? X6 for sure, because of what we just said. Now, with this single y, there's an invisible 1. Okay, I'm hearing y3, y to the power of 3, yeah. Yeah, y cubed. Zoom saying something? What you got, Zoom?
X6.
Yeah, you agree?
I think that's,
Yeah.
Yeah, nice, perfect. 2 agreements from Zoom, for sure. Okay, so again, you can show it out by multiplying. A cool thing to recognize with this, though, especially when the questions get very, very big, is that you can write it like this. Instead of doing how I just showed you, instead of 3 sets of brackets, repeated thing, watch. Each thing inside the brackets gets the 3 that's on the outside. That's the good way to do it. Okay. What's the first thing you see in here? X squared, right? So that goes inside like that. What's the next thing you see in there? A y like that, right? Okay, it's a bit faster. This bracket is in between. What happens with the 2 and the 3? Multiply them together. And there's your x6 coming out. The y on the outside, invisible 1. You get your y cubed and you're done. Okay. Now let's see what else, because I think there's some pretty busy questions coming. Yeah, another example here, right? Just split up the brackets if you like. Okay. Each of them get the result there. So the first one, on your marks, get set, go. What's the answer? What do we do in this situation? 2 to the power of 5. How'd you get the 5? Adding them together. Why do you add them together? Why do you add those exponents together? There's a secret though. Multiplication. Yeah. So you're right. That is the way to do this. Why? Because it's multiply. The second one. Let's see. I'm going to call the names. Lana, what'd you get? What do you get? Oh, really? It's too far. Okay. See if I can. I might have to do this. Pump it up a little bit. And I'm kind of stuck with where I am here, but oh, I know what I can do. Yeah, I'll just watch. Click and drag. You can see the whole thing again. Look at that. Beautiful. Boom, 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 boom. Did all those. Closer look. Closer look. Here we go. How's that one now? A little bit better? For sure. 3 to the power of what? For the answer. 5 indeed. Perfect. Next one. Minus 4 to the power of what? 5 again. Yeah. What's the next one? 5 again? Not very original, eh? A lot of cut and paste going on. Okay. Now this one. I heard that. What do we get? Yeah, this one I'll show you in a couple of steps in case you need a refreshment. On the board is on the screen rather is this. Each thing gets the exponent from the outside. 3 there, x there. 3 to the power of 3, 27. Indivisible 1. 1 times 3 is 27x cubed like that. Yeah. The next one. Good. It's not 3 times 3. It's 3 to the power of 3, which means there's 1, 2, 3 3s multiplied together. That's what this symbol means. 3 times 3 times 3. Spread it out. Okay. What's 3 times 3? 9 times 3. Woo! See? Good times. Right here. 27 like that then, eh? It's the same style, same situation. What's the next one going to be? Fours all over the place. Yeah, I think it will be a 16 there. Well, this brown looks good down here. How does it look up there? Best one, I think. Okay. There's 4 on the outside. Right? One set of brackets for the 2, 1 for the y to the 4, not 8, all right? From what I just heard. 2 times 2, 4, 2, 8, 2, 16. Yeah, exactly. What happens here? Did I copy this right, or is someone playing games? Yeah, 4 times 4, 16. It's true. Beauty. That is true. How you guys feeling about this? Not bad? It's coming back. Okay. So you see, you can just get a little bit bigger. This first one's cut and paste. We just did that one. This one down here, though. No exponents on the outside. So we going back to our first rule there with multiplying. Numbers first, then the x's, and then the y's. So for the numbers, what do we got there? Not bad. It's multiplying. So for the numbers, we got a 2 times a negative 3, right? Okay. Minus 6. Yeah. For the x's, we got x squared from the first bracket times y for the second one, right? X to the power of 3. It's true. For the y's, what do we got? In the first bracket, it's a 3. Yeah, nice. It's 5, right? So you can do this in your head. I wrote them out separately, right? But the result is that you get minus 6, x to the 3, y to the 5 is the final result for that one there. Yeah. Okay. These ones. See, pretty busy already, right? What the heck? A little different looking already, right? Okay, so what do you want to do? Or any ideas what to do? Yeah. What's a secret? What's a smart way to start one of these? Yeah, I think at the back they got it. Yeah. What do? You take a look at a bracket and simplify it first. All right. So this isn't a hard rule. Sometimes you want to keep stuff in there, actually. So it starts to be a little tricky as a teacher to say, do this all the time. But try this first is what I will say. Okay, so looking at that first set of brackets there. What can be simplified? Well, I'm going to work vertically like this. We got a y3 on the top. Oh, that y to the 3. Y to the 3 on the top. Y to the 1 on the bottom. That's right. Those y subtract. You get y to the 2. X stays. Okay, so that's what our first bracket can simplify to. That's not bad. Okay, what about a second bracket? Yeah, this is the original one here, just so video can see it later and such, right? But what gets simplified? The x's do, just as you said. Nice. What does it simplify to? X to the 2, x squared, yeah. Y squared like that. Perfect. Final answer. You can do it off to the side if you want, but I think you guys have some skills there. Yeah, we got an x to the 1 here, x to the 2. Add them up because they're multiplying. X to the 3. Y2 and a Y2. Yeah, Y4. Good work, Mark. Yeah, add them up like that. Okay, I think this is the last question. This one is given because it's has some dividing in there, right? Dividing fractions in particular. Dividing fractions. This could be a Hollywood horror story for some people. What do you got to remember when you're dividing fractions? There's numerator, denominator is part of it. Something about that. Times is part of it. Yes. Simplify is smart. Yeah, that's a good idea. Times. Yeah. Way to way to repeat what he said. Nice. Oh, you didn't hear? Oh, okay. Independent. Good. The situation is this. I'll do it with numbers and then show you with the screen up there. If you had 2 divided by 5 over 3, what you want to do is you want to flip. I'll say it like this. You want to change the division to times and then flip this second one. Both together, right? For me, this goes back to grade 6, I think. So the division becomes times. Flip upside down. Okay, and then you work it out. Okay. Working out you got one thing. Make sure your times don't turn into X's. Okay, that'll confuse me. Might confuse you along the way. But also remember with multiplying fractions, top times the top, bottom times the bottom. That's an invisible one when it's just a regular number like that. So 6 over 5 is what we get here. Simplify this or reduce it if you can. It's the official language. All right, so now taking a look at our screen there with X's and Y's and all that. Same thing. Okay, that division turns into times. Second thing turns upside down. Second thing, second expression. Oh, you're not going to see that very well, eh? Do it like that. Second fraction.
Thank you.
Yeah, you're welcome. A little better than the other version, eh? Where was that? Goodness. Was this all behind the screen? Anyways, there it is in case it was behind the screen. Okay, the division part here. Divide to times, upside down. Final answer. Same here now. Four x cubed. This part is not so interesting yet. This part is, though. 2x y squared, like that. You guys give me the final answer already? I want to do my teachable thing was just switch this first of all. You know what? There's a lot of x's all over the place. I'm going to change this to a big fat dot. Usually it's a smaller dot, but you see what I did here. Okay, so that's my times now. This goes upside down. Why? Because that's how it works. Okay, and this is just copied down from earlier on. I think we're good to go now, eh? Okay. What's a clever thing to do? Starts with sim and ends with plify. Yeah. So what can be simplified in the first fraction here? Simplify means like dividing out, right? I think the y is for sure, right? Okay. So we got 1 on the top, 2 on the bottom. Cancel them out. So what are we left with? This y is going to cancel with one of those. So yeah, it'll be left with over y, like that. All right, do we need to show you? Remember, this is 1y here. This is 2 y's side by side. One of them will cancel out. One will be left on the bottom. Next thing, anything over here? No, that's not very exciting yet. That's 2x like that. Okay. But now, here's what we can, I'm going to show you this step, but we can actually just miss it along the way. When you're multiplying fractions, it's top times the top, bottom times the bottom, right? So officially, this comes next. Those are all on the top together in one fraction. And these are all on the bottom, written in order, in the bottom of the fraction. What do we do from here? We simplify. Okay. What I'm suggesting is that we can actually simplify if we're careful. We can simplify here. This 4 is going to divide with this 2. This 4 is going to divide with this 2 when they're multiplied together, right? Yeah, well, check this out. The x's will divide, these x's will divide at the earlier step, right? It's a little shortcut. But anyways, top times the top, we get this all together. Bottom times the bottom, that all together. Let's do it. 4 divided by 2, 2. X cubed divided by x, x squared. Nice, right? One's gone. Y to the power of 2 divided by y, just y only. Done. Yeah. Okay. Is it pi time? 314 over. Okay, that means class is over, or at least this part of class is over. What do we got next? Yeah, that's what I thought. So I'll put this back so you can copy it down. I got 1, 2, 3 pages of homework. Now, looks like a lot. There's like 20 questions on each. But honestly, a lot of them are going to be 2 to the power 5 times 2 to the power 7 is what? Okay. But to help you out, odd numbers only. Okay. All right. So just a second. I forgot. I got Zoom in my head here. So class, you guys take, you can take 5-minute break if you want. Go and stretch. Come on back. Yeah, I'm going to finish up with Zoom and then we'll do this homework stuff. Zoom, if you are still there,
Yeah.
thank you for staying by. Yeah, from class, the homework goes on that.
Okay.
That goes right there. You can just put all the homework there. The from Zoom.
Yeah.
Yeah, today's homework is in Teams already.
Can I just take the phone out?
Okay.
So you can get started on in 5 minutes. So you can get started on those.
Mm-hmm.
Now, while the class is taking a break and getting homework and such, what questions do you have for me?
I have now last day 5.
Okay.
Question. I have many. I have 8 and 15 and 20 and last one
What? That's not so many.
and last one 28.
That's easy.
We done all the questions,
Odd numbers.
all numbers?
Yeah. You can write that on the board if you don't mind.
Teacher,
Yeah.
are we supposed to do this also on the paper and send it to you, or do we just do it on the laptop?
Paper and then send it if you can.
Okay.
That would be what do you prefer? You got to show all your work. That's the thing, eh? Not just the final answer. Zoom, which one? Number 8?
8. Yeah.
Can you see it on the screen?
Yes.
All right.
Minus 2 square 3 plus 3 square 27.
Okay, so I'm going to write it down on my camera and then I'll get the camera up for you. Minus 2 root 3. That's a plus. 3 root 27 equals, equals what? Equals, I don't know. Let's take a look. Okay, that's what I got for you. So what's your first step? What's the first thing to do?
Mm. For me, I do a prime number, but 27, it's already prime number. For that, I ask you.
27 isn't prime. 27 can be broken down.
Oh,
Aha. So the secret is, what's 2 plus 7 equal to?
what?
There's a secret here. It's 27, right?
Yeah.
What does 2 plus 7 equal?
9.
Nice.
No,
It's 9, right? Does 9 divide by 3?
yeah.
Yeah. So 27 divides by 3 as well.
Three.
Yeah. 3 times what gives 27?
9. 3.
Nice.
9.
Nice. So 9 can be broken down like that then as well, right?
Oh, yeah.
And that means we can do stuff up here now. Minus 2 root 3. That's 3. We got these now on the inside, right?
Yeah.
Yeah, perfect. What happens next?
So, 10.
What can we do with these 3s now?
Can go out.
Yeah.
One. Become one.
No, only 2 of them go out.
Oh, okay. Yeah,
'Cause it's-
one inside.
One stays inside. Nice. So these 2, those are going to go like that. That 3 is going to stay. 2 root 3. Look at that. 3 times 3 is 9. So we get this. Final answer. You having fun over there?
Um. So, mm, um, we have to like 2 times 3.
No. What we got is a minus 2 here,
Mm-hmm.
root 3, and a plus 9 root 3. So as long as these are the same, they're both
Mhm.
square root 3s, right?
Yeah.
We just work with the numbers here.
Oh, okay.
What? So watch this thing here. It's kind of like minus 2x plus 9x. You see, both x's, both square root 3s.
Mm-hmm.
So what do we get?
11.
Because it's a minus.
Oh, minus 11.
No. How it works. This is like what you do is you treat the first number as like a starting number, okay?
Mhm.
And then you add 9 to it. So watch. I'm going to draw a little picture here. These are like stairs. This is a nice idea for this.
Mhm.
So if we're down by 2, that means we're down 1 stair. That means we're right here on this level. See, that's the ground. You can see that, okay?
Yeah.
Right? So we're down by 1, down by 2. We're here. Now we have to go up by 9. So you go up by 1, up by 2, 3, 4, 5, 6, 7. Oh, I'm going to run out. 8, 9. So now where are we? What stair are we on? Let's see. Got -1. Right. The ground counts as 0.
Mhm.
So that means we are on the 1, 2, 3, 4, 5, 6, and there it is.
Seven.
Yeah, 7.
Mhm.
Plus 7 now, √3.
Oh, okay. Got it. Thanks.
Okay. There are some shortcuts with this, but we can maybe check them out next day, okay?
What?
There are some tricks we can do with adding and subtracting integers.
Where I can find them?
You know what? I'll find them and put them on Teams for you.
Okay. Thanks.
Okay. Yeah. Good. From Zoom, one more question. And I have to talk to the class for a bit.
Number 15.
15, sure. So let me get it. Try and get it somehow. Oh, there we are. $15. Yeah, same thing. That 20 has to be broken down like we just did.
Yeah, it's become 2, 2, 5.
Nice. So what happens with those 2s?
2, 2, 1. It's become outside,
Yeah,
and 5 is still inside.
exactly. So yeah, I'm going to use your work because it was correct. -3, 2, 2, 5, and then minus √5 like that, right?
Yeah.
Beautiful. These 2 go out.
Mhm.
-3 times 2. Left with what? √5. Subtract what? √5. Okay. What happens up here? The 3 and the 2. 6
Yeah.
it is. With that negative in front, that makes it. Yeah. Zoom class beat you. Class said -6 and they're right. Multiply those together. √5 there. This counts as a subtraction. It's 5. Okay, now we can get into stairs again. Imagine you're 6 stairs underground,
Mhm.
and then you go down for this negative. You start at -6. You go down by, there's an invisible 1 here. So,
5.
well, there's an invisible 1 in front here. So
1.
if you, yeah, that's a 1 there. So if you're 6 stairs under the ground and you go down 1,
-7.
see? That's the picture to have in your, the picture to have for this type of question. Yeah, -7 it is.
Oh, yeah.
Okay,
More clear.
nice. Perfect. Okay, what do you think? You want to try those other 2 questions then?
Yeah, I will try the 2 more I have to ask, but I will try by myself, and if I'm not if I'm
Yeah.
still confused, I will ask.
Yeah, perfect. And I worked with teams yesterday. You take a picture, you show me,
Mm,
I'll get back to you.
Okay.
Okay?
Yeah.
Perfect. Zoom. So I'm gonna let you both go, and then I'll see you tomorrow then.
Okay. Thank you.
Okay.
Okay, thank you. Bye.
Bye bye.
Bye.